This is Richard Browning flying a 1050 horsepower kerosene fueled jet suit, which is about the power of most high-end hypercars. But did you know that his company Gravity Industries has actually been working on an electric jet suit for a number of years now? Gravity's original jet-fueled powered suit has attracted a lot of attention online. With a top speed of 85 miles an hour and a flight time of 5 to 10 minutes, this original jet suit is being trialled for military operations and rescue missions. So why have they been trying to make an electric one, and how close is it to the performance of the jet fuel powered suit? Part of the motivation for the electric jet suits is to remove the high temperature emissions which could stop the suit being used in some scenarios. These emissions are increasingly problematic as you can't filter the exhaust gases like you can in a car, because it would massively reduce the thrust from the jets and therefore limit the speed you can fly at. However, the main motivation for developing the electric suit might surprise you. See, the Gravity jet suit works by something called thrust vectoring, which in this case is a fancy way of saying you move your arms around to change direction. By adapting the angle of the jet engines, the pilot can therefore control their flight. This apparently provides a much more natural feeling than traditional jetpacks, and this is the reason they are instead called jet suits. However, this actually provides a problem that electric jet suits can fix. When learning to fly the jet suit, it is said to be quite difficult to control until something mentally clicks for the pilot. Up until that point, the pilot has to deal with loud and extremely hot jet engines that aren't going where they want them to go. Therefore, an electric jet suit proves the perfect training vehicle for future pilots. Not only is it cooler and quieter, a tether to the pilot could also be used for power, meaning you wouldn't have to keep refueling every 5 to 10 minutes like with the kerosene suit, though this isn't currently being done. But clearly the electric jet suit can also work without the tether. So let's see how it works and what makes developing an electric jet suit so difficult. The electric jet suit consists of 6 electric ducted fans, 2 on each arm and 2 on the pilot's back. These ducts not only keep the pilot safe from the spinning blades, but also enable the direction of the air to be controlled for the all-important thrust vectoring. Additionally, because there isn't enough room for annoying small swirling vortices to develop at the tip of the spinning blades, the efficiency of electric ducted fans can also be considerably higher than a naked propeller. Each of these ducted fans use 16 kilowatts of power during flight, which gives the suit a total power of 96 kilowatts or 129 horsepower. This is a lot less than the kerosene jet suit's 1050 horsepower, so the electric version is clearly going to be considerably slower for now. However, Gravity's prototype electric jet suit uses commonly available brushless DC motors, and there are a number of motor breakthroughs that could happen in the coming years which would enable the suit to become much more powerful. For me, the most interesting of these is superconducting electric motors, which cool the motor windings down to around 75 Kelvin, where certain materials no longer have any electrical resistance. This means that the electric motors become incredibly efficient, and motors like those in the jet suit could produce many times more power than is currently possible, all without overheating. In fact, a European-funded project is already developing a superconducting motor prototype aimed at electric flight. So make sure to subscribe for a future video covering that in more detail. The next part of the jet suit is the battery. And of course, this is where even more challenges come in for Gravity's engineers. Having enough energy stored in the battery is extremely important if the suit is going to fly for a reasonable amount of time. In this prototype, the battery holds just 3 kilowatt hours of energy, which doesn't seem like much when you consider a Tesla Model 3 has up to 75 kilowatt hours. However, the issue with adding more batteries is that you increase the size and weight of the jet suit, and until we have more powerful motors, this would likely cause issues when the pilot tries to take off. So this begs the question, how long can the electric jet suit actually fly for? We can do some basic calculations that say if we have 3 kilowatt hours of storage and we are using the maximum power of 96 kilowatts to fly, we should be able to fly for 0.03 hours or just under 2 minutes. However, the batteries have another irritating property that means getting this full 2 minutes of flight time is almost impossible. This irritating property is that when you draw current and therefore power from the battery, its voltage starts to drop due to the resistances within it. It is also worth noting that this is different to the gradual decrease in a battery's voltage as it discharges. This has a number of impacts, one of which is that eventually the voltage will drop so low that you won't be able to spin your electric fans fast enough to stay in the air. This phenomenon is known as voltage sag and has been a major challenge for Gravity's engineers. Initially, this effect was so bad, the first prototypes could only use around 12% of the battery's capacity before the suit shut down, resulting in a flight time of just 15 seconds. However, by reducing the resistance in the battery pack, they are now able to use around 40% of the battery's full capacity, and flight times are now approaching 1 minute. This still clearly has a way to go before reaching the 5 to 10 minute flight times possible from the kerosene jet suit. However, we are also seeing many developments in battery technologies every year that will make the electric jet suit better and better. And for context as to what may be possible in the coming years, here is the original jet suit flying just 6 years ago. If you like this video, please like and subscribe, and check out this video on an insane nuclear fusion breakthrough.